So it's possible that some of our radical expressions might have variables underneath them, and some of those variables might have exponents. And so we just want to look at a couple of examples about how to handle variables that have exponents. So I have a simple rule up here that you can follow for this, and it says that you can simplify variable expressions that are under a radical by just dividing the exponent by 2. And you might be wondering why that works. Why do we just divide by 2? Well, if you take a look at something, if I said something simple like 5 times 5 is equal to 25, well, it makes sense that this is really just 5 squared is equal to 25, right? And then if I were to do it the backwards way, if I were to say, well, what's the square root of 25? It's really just the same thing as the square root of 5 squared, which is just 5, right? Which is 5 to the first. So if you notice what ended up happening was, when I square root something, it ends up cutting the exponent in half. And that'll actually work for any expression you try with regular numbers. So I can apply the same thing here. I can say, what number, when I multiply it by itself, in this case that number is going to be a variable, right? What variable, when I multiply it by itself, gives me x to the fourth? Well, the answer is x squared times x squared gives me x to the fourth. So I can just cut this in half and say, no more no more radical, just x squared. Okay? Same thing over here. I can say, what number, when I multiply it by itself, gives me x to the 14th? Well, if you remember your exponent rules, x to the 7th times x to the 7th is x to the 14th. So I can just say, well, this is x to the 7th. That works, right? So this is going to work for any expression that has exponents in it, okay? So if I take a look at something slightly more complicated down here, if I were to take this expression and break it up and say, okay, well, the 3's here, what factors, perfect square factors are in 44? Well, this is really 4 times 11. So if I break this up, I'm going to say the square root of 4. Okay, the square root of 11, just like we did on the last examples that did not have variables. And then w to the 8th is something that I can also square root. Using this rule up here, I can just cut the exponent in half. So when I simplify the parts that I can simplify, I can say this is 3, well, the square root of 4 is 2. The square root of w to the 8th is just cut the exponent in half, w to the 4th. Okay? I don't know the square root of 11, or it's not something I'm going to get a nice integer for anyway, so I'm just going to leave that where it is. So now when I put this all together, it's going to be 6 w to the 4th, and then the square root of 11 is just going to stay underneath the radical, like that. Okay. Same thing in the second example, 10 square root of 16. I'm not going to break up because I know what the square root of 16 is. Right, the square root of y to the 18th. I also know that because I can cut this exponent in half. So this is going to simplify completely. 16 becomes, the square root of 16 becomes 4. The square root of y to the 18th becomes y to the 9th. No more radical anymore because I performed the operation. So this is going to simplify into 40y to the 9th. Okay, so let's take a look at some examples where maybe it's not going to cut in half as nicely. Right? If I had x to the 7th under the radical like I do here, I'm not going to say x to the 3.5. We always want to keep our exponents as a nice integer if we can. So what we're going to do in these cases is we're going to treat these similar to how we treated numbers, right? If I get something like the square root of 12, we said, well, if I break this up into pieces, right, I can at least square root part of it, right? I can square root the 4, I can't square root the 3 nicely, right? I can do the same thing here. If I break off one extra variable, that 7th one that's really stopping me from being able to do this, here's what I get, right? X to the 6th I can square root, and that extra one I can't. Right, so I'm going to at least square root these 6 and say, let's turn this into a 3 without a radical anymore, and that extra one. Right? So in this case, I would say this is simplified. I at least square rooted the 6 that I could. The 7th one stayed under the radical, and that's a little bit simpler now. Okay? Same thing with the second example. Here's how I'm going to break this up. I'm going to say the square root of 9 and the square root of 2, because 9 times 2 gives me the 18, and 9 is a perfect square. Right? I wouldn't use a 6 and a 3 here. That wouldn't make sense. Okay? And then I'm going to take the 12 of these 13 that I can square root, and then just leave that extra one underneath the radical. So here are the parts that square root. I know the square root of 9, that's 3. I know the square root of x to the 12th. I can cut 12 in half and get no remainder. So I'll say that's x to the 6th. And these two parts, the square root of 2 is not something I can do in my head, and this extra one I also can't cut in half. So I'm going to say this is 2x. So I multiply those back together underneath the radical, and I would say that's going to be my simplified expression.